folks. My name is Uday Tatiraju. I am a tech lead and a principal software engineer at Oracle. My background and experience is in e-commerce platforms, search engines, machine learning, and distributed systems. On the volunteering front, together with my fellow AI Council members, I help strategize and build technical resources on artificial intelligence and its subsets like machine learning. And this is part of CompTIA's AI Council. I am also an editor at InfoQ, where I write news pieces and articles about technology, and they're primarily on AI, ML, Java, and DevOps. Let's get the safe harbor statement out the way. I want to emphatically state that the views expressed here, which are pretty opinionated, are my own and not those of Oracle or any other company that I refer to in this presentation. Having said that, let's move on to the fun stuff. Here's the agenda for the presentation. I'm going to start by talking about conversational AI lifecycle, its various phases. And as we go through the various lifecycle phases, I'm going to talk about the tools and frameworks that can be used for each of the phases. I'm then going to call out the possibility of doing polyglot programming in order to build and deploy bots and the associated services that these bots can talk to and fulfill end user requests. I'll briefly talk about the benefits of going polyglot. And then I'm going to talk about the everything ops, essentially the principles and processes that have gathered traction in the tech community to rapidly and automatically deliver software applications and services. Uh, Also, please note that we will be viewing some of the lifecycle phases of conversational AI primarily through the lens of Rasa open source. And as many of you know, Rasa is a machine learning based platform that allows us to build context aware conversational assistants. Let's start with the first phase in the lifecycle, which is the design phase. As you might expect, building a conversational bot starts with the design. In this phase, UX designers, more specifically conversational UX designers, business analysts, and other stakeholders get together to chart out the scope of the bot, its domain, its purpose, and then start writing conversations. You can use prototyping tools like Bot Society to design these conversations. And then, of course, you have to provide both sides of the conversation, the user message and the bot message, like how you envision the bot to respond. And as in the design phase, you try to figure out the bot's persona, how it should handle messages outside its purview, basically the fallback mechanism in conversational design speak, and also how to set up user expectations right from the get-go. Other key things to consider, in my opinion, are privacy and security. As is the case with any software product, it is paramount to include security and privacy aspects in all phases of the build and deployment lifecycle of your conversational AI assistant. Now, these examples include, especially in terms of privacy, it could be the personally identifiable information that you set to use. For instance, if you want to greet the user uh, as part of a bot message, would you just use the first name or would you use the last name? And in another example, if you want to verify the user's account number, do you just ask for the 4 digits or the entire account number? And then how would you store these conversations? And if you do, what's the retention policy? And otherwise, do you scrub the personally identifiable information from the logs and the database? What's your privacy policy? And when would you notify the user? Is it upfront when the user initially starts a conversation with your assistant? Uh, all these sorts of things are necessary to talk about, discuss, and strategize on. And the design phase is where you would want to do all of these things. And once you have few conversations, be it happy paths and potentially a few unhappy paths laid out, you can move on to the next phase, which is the development phase. Now, as an engineer, I spend a significant time in the develop phase, so indulge me as I ramble on. Uh, so the develop phase, it involves data collection, data preparation, training models, evaluating and fine-tuning models, and in most cases, architecting and building integration hub that gets invoked by your bot in order to, let's say, execute actions or what we're calling skills these days. These skills can include things like turning on a light bulb, providing insights into a customer's monthly spending habits, or creating a service ticket on behalf of the user. From a conversational AI standpoint, part of the data collection and preparation entails things like providing, labeling, annotating, data, more specifically the intents and the entities. And in the Rasa world, you also create slots and maybe synonyms, and then stories, which initially would be based on the conversations provided in the design phase. You can also externalize the bot responses to keep them separate from your training data and potentially giving your designers the ability to tweak the responses, probably to enhance the user experience or to correct grammatical errors or whatever. And so by externalizing the bot responses, you don't necessarily have to retrain and redeploy the model. So it's highly recommended that you externalize the bot responses using a REST API service. And so once you have enough data, you start training your NLU model and perhaps a machine learning based dialogue management system like Rasa Core, which actually uses rules and machine learning model to manage user conversations. And as with any machine learning model, you get to tweak and fine tune your hyperparameters, your configuration settings, and whatever that needs to be done in order to achieve a desired accuracy score and decent metrics that you care about. Of course, if you're using Rasa, you can use Rasa's command line interface to evaluate the models, compare different pipelines with the various parameter settings and configurations, compare core policies, and then fine tune the NLU and the core models. But if you're building a bot that does some work on users' behalf, you are most likely than not going to integrate the bot with external services. Like for instance, a finance bot may call an account spending summary REST API, parse the response from that API and then convert into a conversational response and send it back to the user in natural language. And in Rasa, this integration point, this hub that's responsible for integrating with other services and probably executing its own business logic is what they call an action server. And it is deployed as a REST API, and therefore it lends itself to any programming language. Of course, depending on your enterprise, your team's expertise, like if it's a Java heavy shop, you can create the action server in Java. And I can vouch that there are plenty of tools and libraries to help you rapidly build and iterate the REST API. Same is true with other programming languages like .NET or any other like Go or anything else really. And of course, Rasa provides a Python SDK, and you can use that if you wanted to go that route to build your action server. An additional advantage of using a language like Java, for instance, is that it's statically typed, it's highly performant, and if you go the native image route by using a platform like GraalVM, which is all the rage these days, you can build a really lightweight Docker image, and the container that uses this image spins up very quickly, and it doesn't use a whole lot of memory, and it really helps in order to provide the end user with a reliable and efficient service, especially in a Kubernetes environment. And I just want to call out a few important things here. Building conversational AI is still software engineering for the most part, at least. So it augurs well if we follow best standards and practices like the 12-factor principles. And at the enterprise level, leverage the standards and practices incorporated by, for instance, your community of practice group. And since most conversational AI bots are greenfield projects, it also makes sense to embrace cloud native off the bat. Conversational AI, can also involve integration with external services like databases, eventing queues, REST APIs, distributed logging. All of these obviously increase the complexity of building and running the bot. So I would recommend that you include instrumentation, what we call observability, and some sort of embedded resiliency when you invoke external services. Maybe use a circuit breaker and a retry policy and incorporate that throughout your bot stack. There are many robust tools and libraries to do that, and they're also available in all popular programming languages. Open telemetry, the new kid on the block, is one such tool that you can leverage to include observability within your bot stack. And like I mentioned, it is paramount to include security and privacy aspects in all phases of your assistance lifecycle. You should use secure coding practices to avoid common pitfalls like SQL injection, cross-site scripting attacks, buffer overflows, and all sorts of threats. Definitely make judicial use of authentication and authorization mechanisms, secure personally identifiable information, like I mentioned before, securely store and retrieve secrets and other sensitive configuration while you deploy and run your assistant in production, and have auditing in place, and obviously use automated tools to detect security vulnerabilities and threats. So the next phase in the life cycle is the test phase. You will notice that there are multiple types of testing. One type involves evaluating and validating your model, like the Rasa NLU model or the Rasa core model. And in case of a voice bot, perhaps you have a wake word detector model, so you want to test and validate that model as well. And as part of model testing and validation, it's recommended that you generate reports, things like F1 score, precision recall, generating histograms, and things like that. They definitely help you visualize the scores and quickly identify issues, identify regressions, and uh, these scores can actually be potentially used as gatekeepers in your CI/CD pipeline. So if a score is less than a certain threshold, you'll just fail the bill, things like that. And if you're using Rasa, it provides the ability to test your conversations, to test the stories. So you can, and you should definitely run them as part of your CI pipeline. Ensure that the various happy and unhappy paths are tested and validated. And again, if you're using Rasa and Action Server to build your conversational assistant, you should, like we do in software development, unit test the logic. There are plenty of tools for unit testing. For example, if you wrote an action server in Java, then you can use a library like JUnit. And if you're using Python SDK, you can leverage the unit test module, which is in fact inspired by JUnit. And during unit testing, it also makes sense to mock external service calls to speed up the tests, among other things. And you just want to, since, in unit test, you just want to test your logic. For example, you don't have to make an actual REST API call if the goal of the unit test is to make sure that a specific slot in Rasa is set to an expected value. And of course, as the bot project matures, you should start writing and executing automated integration tests. Again, there are a lot of mature tools and frameworks to help you with the automated integration testing. There's this tool called Spock that helps you write behavior-driven specification testings. And it can also act like your internal product documentation if you write behavior-driven specs. So that's pretty cool. And you can use contract testing tools like Pact to make sure that your REST APIs are working as expected and not breaking any sort of backwards compatibility. And of course, the popular Selenium tool can be used to do automated end-to-end testing of your bot at the, say, at the bot's web interface level. After the test phase is the deploy phase. So let's take a look at what goes on in the deploy phase of a conversational assistant lifecycle. Like I said, the chances are you're most likely dealing with a greenfield project and you went cloud native, so you can definitely deliver your artifacts as Docker images, which will be built by your CI pipeline. And you can also incorporate a standard practice and use tools like Anchorage to validate, scan, and certify the Docker images that you build for deploying your conversational assistant. And obviously, in a cloud native setting, in a Kubernetes environment, you're dealing with namespacing, configuring service load balancers, using certificate managers for SSL, TLS, and you'll be dealing with scale and scale out configurations to provide high availability via redundancy and things like that. And if you already have a mature CD process, you can go ahead and leverage that process to deploy your conversational assistant along with its accompanying services, just like you would do with any regular software application or service. If you don't, that's cool, no worries. You can start creating automated continuous deployment pipelines and use one of the popular deployment strategies if you want to, like the recreate deployment strategy, the rolling update deployment strategy, or the blue-green deployment strategy. I mean, there are pros and cons of each of those strategies, and there is a complexity involved. So depending on the use case, you can pick one of those deployment strategies or create your own custom strategy as well. Complementary to the deployment strategy, and before you make a new version of your assistant and or its accompanying services go live, you should be looking at automating or semi-automating and running some deployment testing strategies just to make sure that the pod doesn't unexpectedly break because of a regression or a bug. And so Canary, A/B, and shadow testing strategies are some of the popular choices for you to do that. And if you are using a CI/CD tool like Spinnaker, you can help. It can help you automate these deployment and testing strategies. So watch out for that Spinnaker tool, or take a look at it. Off late, a new resiliency strategy has emerged. It is what is called chaos engineering. Not an easy setup, I must say, but done right, it will help you identify and fix weak areas of your assistant infrastructure and enable you to provide and ensure that you provide a great user experience. And if I have to, in a nutshell, talk about chaos engineering, I would say it's a way to experiment on your production systems to ensure that the system can withstand high loads, unexpected conditions, and still provide a reasonable, even though slightly degraded experience, and then quickly bounce back to stability. Also, part of the deploy phase is to securely handle secrets and all sorts of sensitive information and configuration. You can definitely use services like HashiCorp or Kubernetes Secrets, which are purpose-built for this specific thing. You should also plan and build migration strategies if you have to. Make sure that your bot is backwards compatible so in-flight conversations don't break midway because of a recent upgrade. And services don't change the output payloads that can cause, for example, the action server to break because it's unable to parse the new REST response payload. You might also be dealing with migration scripts, so you might want to run certain migration scripts, for example, in order to update a database schema used by your assistant or its accompanying services. So this is all part of the deploy phase. And once you deploy your conversational assistant, the next phase entails monitoring it, right? You want to know how well your conversational assistant is doing. There are multiple types of monitoring depending on your infrastructure setup, your bot's complexity. If you're using Kubernetes, the kubelet, the process responsible for managing the Kubernetes node, it uses health checks. They can be simple health checks, made up health checks, or something that is provided by your conversational assistant services and application services. So it's obviously a good thing to provide your own application specific health checks that can be used by the kubelet, and to make sure that the pods that are running your application, running your bot, are ready and alive. So for example, if the Rasa server or the action server gets into an unrecoverable state and stops responding, the kubelet will start spinning up new pods. And the number of pods obviously depends on the configuration, but yeah. So health checks are used to kind of make sure that the pods are ready and alive. And when it comes to other metrics, there are system metrics, application metrics. Uh, when you're talking about system metrics, you're dealing with memory, CPU, disk usage. All of these things can be monitored, and they can be used to scale out and scale in your bot service and ensure the stability and responsiveness of your conversational assistant. And depending on the programming language that you used, you can collect and monitor language specific and application specific metrics, right? So for example, if the action server is built on Java, you can monitor JVM metrics, among other things, and to make sure that you have a smooth operation. There are popular tools to collect and view these metrics. Prometheus and Grafana are the popular choices these days. They can be used to collect and visualize all these metrics. And both these tools allow you to set up alerts. You can do alerting to notify support based on certain SLAs or certain thresholds or configurations. Obviously, depending on your use case, you can do that. And of course, logging is a very important aspect of any software system. Conversational assistants are no different. So you want to log various events that occur within your bot at various log levels like info, warn, or error levels. And these logs can be used to alert or to detect and debug issues within the assistant or its corresponding integration services, for instance. And word about observability, really telemetry in the software world. It is becoming increasingly popular, especially in the Kubernetes cloud native environments. Uh, Telemetry encompasses all things that we just discussed, right? It entails the verticals like tracing, logging, metrics, and you can use this information to analyze the system behavior. And if you see something wrong, you can then obviously address or correct the wrong behavior or the wrong state of the system. Okay, on to the next stage, which is the review phase. I believe reviewing the real world user conversations deserves its own phase in the conversational AI lifecycle. In this phase, you're basically looking at the real world user conversations and see if your bot failed to handle certain conversations. Most likely it will, because it's unrealistic to expect your bot to answer every question and reply correctly, right? So the unhandled paths, watch out for them, identify them, and then make corrections and adjustments to your model or your responses or to your integrations. You can also use the conversations to pull out and annotate data like entities for further training. And then you can also, analyze user experience as part of this phase. When it comes to analyzing user experience, you can do the explicit way, which is ask the end user for feedback, or you can go the implicit route, which is to figure out the signals within the conversations and detect the overall sentiment and the tone of the user, and then obviously take appropriate action to address the feedback if it's not that great. Basically, improve the user experience. Now, the implicit route is pretty complicated. It's a machine learning project onto its own. So But then, yeah, you kind of do these things in the review phase. And tools like RasaX can definitely be used for some of the uh, things that we just discussed in the review phase, like annotating data and identifying conversations that the bot was unable to handle, and then retraining your model. And as you can see, this review phase feeds into the design phase, and you enter this iterative workflow as you constantly design, build, monitor, and evolve and improve your conversational AI assistant. And I'd like to call out privacy and security again. I made a full slide for that because, like I said before, it encompasses all phases of the life cycle. Always build with security in mind. That is what I tell myself and my colleagues right from the get-go. Always build with security as opposed to, thinking about security as an afterthought. It really bodes well in the long run for your conversational assistant, for your software applications and services, and for your company. So when it comes to privacy and security, you have to figure out how to secure the personally identifiable information. You make sure you encrypt the data in motion, encrypt the data at rest, obviously depending on the business use case. When it comes to securing channel integrations with things like Slack and Facebook, you want to make sure that your connection configuration is secured. For that, you can use a service like Vault. Same thing with external service integrations. If you are making calls to other REST APIs, save those configuration details in a secure place like Vault. Leverage firewalls, make sure that the cross-origin request whitelist is minimal. For instance, in case of Rasa, you probably don't want all the traffic to go to it, just certain traffic through a reverse proxy, for instance. And use tools to do validation and scan for vulnerabilities on your Docker images. Follow secure coding practices. Make sure that you defend yourself against XSS, CSRF, and always validate the user input and probably encode it, because especially in a conversational assistant, you're dealing with natural language, free text. So make sure that you validate. Don't blindly trust the user input if the next step of the bot based on the incoming user message is to execute an action. So yeah. And then you can also use various other tools to do static code analysis and penetration testing. All of these things are very important to ensure that you have a secure um, conversational AI assistant. Okay, now let's turn our attention to what I call the everything ops. It is, as you may have imagined, a combination of tools, processes, and culture that fit into the conversational AI lifecycle. Um, we all know that DevOps was made pretty popular over the course of the last decade. Then there was data ops for database specific operations. Then we had DevSecOps to call out the need for including security in all phases of the lifecycle. And then there's GitOps with the concept of using Git as a single source of truth for code, for config, for infrastructure, and everything. Git allows one to, or the GitOps allows one to audit changes to the infrastructure, configuration, application, and streamlines the delivery process based on the commits to Git. Then there is MLOps that was coined to call out the need to provide additional hooks and provisions to handle machine learning based applications. And ChatOps is not so popular, but it basically entails using chat operations to coordinate and support operations. For example, using Slack, you can raise tickets, support tickets, you can trigger alerts, or you can capture the chatter amongst engineers while they're dealing with a support issue. And that chat conversation can actually act as an audit trail to go back and refer to a support ticket later on. And in some advanced environments, some teams do use Slack, for instance, to issue operational commands. In the end, all of these ops are a combination of tools, processes, and culture to deliver software, to deliver conversational AI assistants, to deliver machine learning applications. So that's why I call them everything ops. And finally, here's a list of some of the popular open source CI/CD tools that support and or that can be customized to support everything ops. Uh, there's Jenkins, tried and tested Jenkins that only provides CI. Then there's this new tool called Argo CD that enables you to implement continuous delivery or deployment. Then there are these cloud native, Kubernetes native CI/CD tools like Jenkins, X, and Tekton. And then the old workhorse Spinnaker, which has been around for quite some time now. You can use that to deploy your conversational assistant, your software applications, be it on-prem or virtual machines or in Kubernetes. And like I mentioned earlier, Spinnaker also provides you with out-of-the-box deployment and deployment testing strategies as well. Okay, I guess most of you must have fallen asleep by now. So here's to hoping that this quick demo will wake you up. The demo shows a CI/CD pipeline to deploy an application called Flock Crisis Center. Basically, Flock Crisis Center is a prototype of a low-code tool that helps users quickly bootstrap info bots, FAQ bots. FAQ about COVID-19. If you want to build that using Rasa, this low-code tool will provide a way to bootstrap. So the pipeline is running here, the CI/CD pipeline. It's deploying it to a local Kubernetes environment. It has multiple pieces. And once it's deployed, we can open up the interface. We can start creating a new info bot. And like I said, since this is a low-code tool, what it does is it uses conversational assistant to build conversational assistant. So here it's asking a bunch of questions about an FAQ bot and an info bot, about the main message that the bot should show, its menu options, and once you give it the number of menu options, it's going to ask you more questions related to each menu option, and you can tell it how to react. And once it collects all the information that it needs, it will use a template and give you a link to download the starter kit. All right, there you have it, folks. Here's the recap. Talked about conversational AI lifecycle, its various phases. Talked about the various tools, frameworks, and libraries that are available in each of the lifecycle phases. And don't be shy to go the polyglot route. Python for ML, Node for web front, Java for integration services, just as an example. And then we also talked about the all-encompassing everything ops, CI/CD tools, and then we saw a quick demo of using a CI/CD tool to deploy a low-code tool that internally uses a conversational assistant to help users bootstrap conversational assistants. Thank you for tuning in.